Alright, welcome to another video. We're going to be working through the book some more. Before I get started though, I learned something today that I want to share. So, I never really used to be a big fan of using Visual Studio Code. I use it just because I think I need to use it, just because I wouldn't feel professional in some way if I didn't use it. But today I figured out a way I can use Visual Studio Code where it's like, oh yeah, to not use Visual Studio Code would be dumb. Like I am using Visual Studio Code and I know exactly why I'm using Visual Studio Code. So this code here I think will probably be okay. Let's use some different codes. So I'll do test. Oops, and for some reason, okay, there we go. Equals, oops. 1, 2, 3, 4, 5, 6, 7. So we'll do for I in test, we're going to say if I is greater than 4 or 5, we're gonna do this var equals hello world, and then we'll say else this var equals too low, and then we'll do yeah, and then that's it. So what I learned today is right over here on this tab, you can click on this, and then you can click Run and Debug, and then this is a Python file, so you choose Python file, and now it will give you this special. Now we see it disappeared because I actually missed a step. Before you click Run and Debug on here, you put in something called a breakpoint. So what you do is you say here I want the code to stop, and you can give it an expression. So let's have the code stop once this var equals hello world. Okay, so when the variable this var equals hello world, the first time that happens, this code is going to stop after I hit this run and debug. There we go. So the code stopped because we can see here this var equals hello world. So the reason this is so powerful is because you see all the variables that are defined now, and you don't have to use a million print statements in the code anymore, because anything you would ever want to print is up here anyway, and then you can go through and look at everything. You get the length everywhere, you get you get even the stuff you can do to it right there. It's just all the stuff I would normally have to use the help menu. I would normally have to use print statements. Well, it's all right here. I don't need to add extra lines of code to see what the variables are defined as, or to even get help on the special built-in methods that the data types have. So yeah, we can see I is now defined as 6. This is the first time where this var equals hello, because 6 is the first time that I is greater than 5. The even cooler thing we can do is we can, now it's stopped here, so we can start it again. Now it's going to stop here again because this var equals hello world. That's our conditional that we have set up here. So you can debug your code and see now we don't get anything because the code didn't stop, because our stop conditional wasn't met. In fact, it didn't have any more code to run because it reached the last element in this list. So really powerful stuff. I'm going to be using this all the time now, and this is officially my transition from grumpily using Visual Studio to happily using Visual Studio, because having these breakpoints, especially with a conditional, is just absolutely valuable. So let's do a arbitrary, and then you can stop it like that. But let's do another breakpoint. So we're gonna remove this breakpoint, and then let's stop the code. Let's do a print I here, and then we'll stop the code on this line. Now I think the code actually stops before. So if you add a breakpoint here, and then you say, well, let's try this. So what we're going to do is hit escape to cancel. We're going to remove this breakpoint, and then we're going to stop the code here. So we're going to add a breakpoint, and we won't add a breakpoint conditional. We'll just stop it every single time. So we're going to stop it when I equals 1. We'll see that. Oh, actually, we're only going to stop it when I equals 6 because it won't run this section of the code until I is greater than 5. So 6 will be the first time. Now, it is true that when you add a breakpoint, you're breaking before that line is run. So even though I now equals 6, and this line of code redefines this var to equal hello world, we can see in our variables this var still equals too low, which is because this part of the code was executed when I equals I is equal to or less than 5. So the last iteration, I was equal to 5, so it triggered this code and it defined this variable to too low. But now the next iteration, where I is equal to 6, even though it goes to the breakpoint is on line 6, it stops running the code before it runs line 6. So we can see this var never got redefined to hello world. So that's important to know. But once you figure that out, it's really nice and easy. So yeah, and then you can add expression to watch. So let's watch the I is greater than 5 expression. Okay, and then we'll go through another iteration. So we can see right now this expression is true. True. Oh, not available because we weren't evaluating that expression. So let's try this again. Yep, and now we're watching this expression. So it's always going to be true if we have our breakpoint here. So let's have our breakpoint. First of all, we'll stop debugging. Then we'll remove the breakpoint here. Okay, now let's have the breakpoint be here, and then let's start the debugger for a Python file. Okay, so now let's watch this conditional here. I is greater than 5. So right now, I is not defined yet. It's going to be defined after, because remember, oh, you know what? Let's do this. So one thing to remember is that the break happens before the line you put it on. So this line of code didn't get run yet, so I was not defined yet. So I'll add the breakpoint here. So I've got one there. You see this red dot is a breakpoint. I'll hit run and debug. Okay, so now we can see um, before this is when it stops. So it hasn't run this print. We can see down here it didn't print. And now we can watch this conditional. So as we go through, we see I is 1 up here in our variables, and we see our conditional that actually is false now. So if we go it again, now I is 2, conditional is still false, I is not greater than 5, and we can see now it did run this line. We printed out 1 here. So go again, yep, we ran this line again, printed out 2, our variable is now 3, the conditional we're watching still evaluates the false. So if I hit this a few more times, and now I hit this to 1 more time here, okay, so now our conditional that we were watching is true because I is 6, which is greater than 5, and yep, but we've only printed 5 because this the breakpoint does not include the line that the breakpoint is on. So if I hit it again, now we're going to get 6. Now this line, the code on and after the breakpoint was run, so this bar gets redefined to hello world. We're on I7, so we're here. We haven't run any of this code yet, so we haven't printed out 7 yet. But since we're checking this conditional, we see that the conditional is true now because we're checking the conditional up to this line. So if I were to, on the bottom here, redefine I, so say I equals 2. So I is actually not greater than 5 now, but let's try debugging this again. Okay, so I is always going to yeah, so we can see I greater than 5. That's going to be true because we're evaluating it before this line gets run. So I greater than 5 is true because we're iterating through this test bar here that we can see. So right now I equals 7, the last one. So I is greater than 5, but the next line of code we're going to redefine it to be less than 5. So you got to be a bit careful with these watch statements. Make sure that you're watching things relevant to how the code will actually execute. But it's a game changer for me. It's a huge tool that I'd never used before, and that was really gonna take my coding to the next level. So I wanted to share that just briefly here for about 15 minutes. And now that I'm done with that, I will move back to the book, and we'll try to hopefully get through all of chapter 5 if that's possible. Alright, so we're on RPM packaging. Just as with Debian packaging, when working in RPM, it is necessary to have the native Python packaging done already. It should be possible to produce a Python package with the setup.py file. However, very unlike Debian, in which many files are needed, RPM packaging can work with just one file, the spec file. If targeting a distribution like CentOS or Fedora, the RPM package manager, formerly known as Red Hat package manager, is the way to go. The spec file. In its simplest form, the spec file, named hello/-world.spec for this example, is not difficult to understand, and most sections are self-explanatory. It can even be generated by using setup tools. Okay, so I'm going to pull up my lab here and we're going to try to make this work. Unfortunately, the last example I just couldn't get to work, so we kind of moved on without actually putting that to practice, but that I really don't see necessarily a need to know that right now, so I'm not going to spend a lot of time on it. I mean, I guess it would be nice to know, but it sounds like there might be an easier way anyway. We'll see how this one works. Okay, so I've got to get this, there we go. And then once this comes on, it generates, or it installs NetMiko, so we'll need to wait for that. So let's keep on reading and then come back and do the example once this is ready to go. The output file in dist-helloworld.spec should look similar to this. Although it looks simple, it is already creating a potential issue. The version is input and requires updating every time. This process is similar to Debian's changelog file, which needs to have the version bumped on each release. The setup tools integration is advantageous, allows further modification to this file if needed, and copies to the root directory of the project for a permanent location. Some projects use a base template that gets populated to generate a spec file as part of the build process. This process is useful if following a rigorous release workflow. In the case of the Ceph project, the release is tagged via version control git, and the release scripts use that tag to apply it to the template via a makefile. It is worth noting that additional methods exist to automate this process further. Tip: generating a spec file is not always useful because certain sections might need to be hard-coded to follow some distribution rule or a specific dependency that is not part of the generated file. In such cases, it is best to generate it once and configure it further to finally save it and make the spec file a formal part of the project. Okay, so we're going to go back and try to run these commands. Okay, and I think we're going to need to run it where there's that setup.py file. Yep, so it's right here. I'll do a tree so it's easier to see. There we go. So we can see the setup.py right here under the hello world. So I need to change directory to the hello world. I could also just stay in this, but then I would need to specify. Let me do that to make that a little bit clearer. So I can stay in this directory, but then I've got to give it the relative path to that setup.py file, which is going to be this hello world directory. I can also give it an absolute path. So to do that, I need to see what my present working directory is. I can find that with the command pwe or pwd, and then I will provide it the absolute path. So the absolute path only starts with this / here. That's because independent of the current directory you are in, you are giving it the directory to look into. That is the alternative of a relative path, which specifies a directory to look into depending on the current directory you are in. So if I give it a absolute path, as I am doing here, it knows regardless of the directory I am in where this file is, because I'm specifying from the very tip top of all possible directories. This is going to be in root, hello world, and then there's your file at setup.py. Alternatively, I can say starting from where I am right now, and we can find that out by using the command pwe -root, look into the hello world directory to find the setup.py file. So you can give it a absolute path or a relative path every time. Now you might wonder, why would I ever use a relative path? An absolute path, I know where the file is regardless of where I am. That sounds like the way to go, because then you don't have that ambiguity in finding the file, and you don't have to make sure that you're in the right directory. The answer to that question is something called portability. So if I were to give this to somebody else, and I were to only use absolute paths, they would have to have the exact same absolute file paths that I have. So they'd have to have the same username, they'd have to have the same folder hierarchy, and that's just not going to happen from system to system. So instead you can use absolute paths, and then all you need to count on them doing is running your code from the folder that you include the code itself in. So much better to use relative paths instead of absolute paths if you're planning on having your code run on different PCs and not just your own computer, as is usually done. So if you're planning to share your code, make sure that you're writing your paths using absolute paths, using relative paths that are relative to the top level folder that your code is written inside of. The alternative to that is absolute paths, which is relative to the highest level folder on the system, but that highest level folder is unknown system to system. It depends on the system. So if you're going to share your code, you can't use absolute paths because you don't know if that absolute path is going to be valid from system to system, but you do know that the relative path is going to be valid, because when you write your code, you get to write the relative paths. You get to decide what those relative paths are. You can't do that with the absolute path because it depends on factors that you don't have control over when you write the code, such as the operating system, the way the username, the way the person who's running it is deciding to run it from where on their PC. So that's the difference between an absolute and a relative path. All right, so we're going to do, we're not going to use the tree command, we're going to use the command python3, and then we're going to just demonstrate this is a relative path here. It's relative to my present working directory, which is /root. We could also give it an absolute path, which would start with the / and then be root / hello world. But we're going to go with the relative path here. And then we're going to enter the next part. All right, let's see if this works. Aha, so it worked. So the output file is going to be in dist hello world. So let's move over to that. Oops. Oh, you know what? So unfortunately, it looks like it generated it in the folder I'm currently in. So yeah, you can see I've got a dist file here instead of inside there. So that's definitely not what I want. So I'm going to redo this. And I'm going to move into hello world. All right, and then I will run this command again, and we'll get that dist folder showing up inside of the hello world folder. Oh, but now I need to change my path since I'm no longer, since the relative path, since it's in the folder I'm in, the file that I'm looking for is in the folder I'm currently in. I don't need to specify a folder for it to look into. It's just going to look into this folder without further specification. And that's where it is. So we can see that is successful there. So let's move into the dist folder. Okay, so we can see it, there it is, .spec, just as is shown in the book. So let's cap that out. And there we go. We've got auto-generated file. It looks exactly like the one that they have in the book. All right, so let's continue on to the next section, which is producing the binary. There are a few different tools to produce RPM binaries. One in particular is the RPM build command line tool. Okay, let's try this. So yum is something relevant to a different distribution of Linux. So I don't think I have yum because I'm running Ubuntu, which is Debian based, but I will try it. Yeah. Oh, it's the command sudo that was not found because I'm already logged in as user. Yeah. So I don't have yum because I'm not using the same distribution of Linux as they're talking about right now. So I'll just skip that command and keep on reading. Note the command line tool is RPM build, but the package is called RPM -build. So make sure that RPM build, the command line tool, is available in the terminal. You know what? Let's just apt get that. So we're going to do apt get install RPM build. Oops. Okay, so I think it's only available through yum, so I won't be able to get that, unfortunately. What is RPM? Oh, Red Hat. Okay. I thought it would be like RHM for Red Hat. RPM. Yeah, so an alternative to Debian-based Linux is Red Hat. Let's see here, Red Hat versus Debian. Yeah, Red Hat versus Ubuntu. So I'm using Ubuntu, but this RPM packaging is meant for Red Hat. Yeah, so they're developed by two completely different entities. And not only that, Ubuntu uses the apt-get for packaging, but Red Hat uses yum. So I won't be able to do the examples that use yum unless I spin up a Red Hat machine, which, I mean, why am I not doing that? I literally have a entire network automation lab just sitting in the other room, so let's use it. Okay, so let's try to get Red Hat on here. Is CentOS Red Hat? I think it might be. Let me ask Google. Is CentOS Red Hat? Question mark. Oh, yeah. Okay, so we can just use CentOS, and that's Red Hat. So if we want to use Debian-based, we can use these Ubuntu VMs. But if we want to use Red Hat-based, we can use these CentOS. Yeah, so we've got two ones we can choose from here. So let's go with the with this one here. So we're going to install that. Oh, so we're going to need the file. So if we just now it's open source, so it should take us right to the link where we can get that from. Yep. So osboxes.org/CentOS. We should be able to. So let's see here. Let's see what version they want. So 7/1810 / 1810. Okay, perfect. So, and we want so we've got the VirtualBox version, we've got the VMware. So let's take a look at what the server wants. So it wants the VMDK file, 64 bits. There we go. So this is what we need. Okay, so now that we've got that, we're going to be looking at so we're going to be downloading it. So I'll put it in the downloads folder. Okay. All right, and then once that is completed, which unfortunately looks like a pretty large file, so it's going to take a bit. The next step will be to upload it, and then, okay, so it's still going to upload it, which unfortunately is going to take a long time as well, but then we'll have a red hat to follow along the examples with. Okay, so this is, next section is producing the binary. Okay, so I'll just read this again. There are a few different tools to produce RPM binaries, which are Red Hat Linux binaries, the alternative to binaries that can be used for Ubuntu. One in particular is the RPM build command line tool, which I won't be able to do until I get that CentOS machine working. The command line tool is RPM build, but the package is called RPM-build, so make sure that RPM build, the command line tool, is available in the terminal. A directory structure is required by RPM build setup tools. I don't know why. It looks like there's an unclosed. Oh, I see. Okay, I had. Oh, okay. I was missing a line here. A directory structure is required by RPM to create the binary. After the directories are created, the source file, the tar.gz file generated by setup tools, needs to be present in the sources directory. This is how the structure should be created and how it will look once it is done. There we go. Perfect. Okay, so unfortunately I can't follow along with this. So let's just keep on going. Oops, and this download here unfortunately is making it. Okay, so I can just get rid of that, and then for my downloads they'll show up in a different tab. So yeah, and I can see a progress bar down here, so that'll be how I see it. The directory structure is always needed, and by default, RPM requires it in the home directory. To keep things isolated, a different location in /opt/repo/CentOS is used. This process means configure RPM build uses this directory instead. This process produces both a binary and a source package with the -BA flag. Output is abbreviated. So RPM build -BA --define. Okay. And I can't follow that along because my CentOS machine is downloading. So we'll just move on. The directory structure at /opt/repo/CentOS. You can see they're using CentOS as well for their RPM packaging for their Red Hat based Linux distribution. We'll have lots of new files, but we are only interested in the one that has the noarch RPM. The noarch RPM is an installable RPM package. The tool produced other useful packages that can be published as well. Look at /opt/repo/CentOS/srpms, for example. RPM repositories. To create an RPM repository, use the create repo command line tool. It handles the creation of the repository metadata. XML-based RPM metadata from the binaries it finds in a given directory. In this section, create and host the noarch binary, sudo yum install create repo. You can create the repository in the same location used to produce the noarch package, or use a new clean directory. Create new binaries if needed. Once that is completed, the package copies. Okay. Yep, so this is on the CentOS machine. Won't be able to run these commands. To create the metadata, run the create repo tool. Although an x86_64 package does not exist, repeat the create repo call for this new directory so that yum doesn't complain about it later. We are going to use the http.server module to serve this directory over HTTP. To access this repository, yum needs to be configured with a repo file. Create one at /etc/yum.repos.d/hello-world.repo. It should look like this. And again, I'm going to need to skip this because I'm waiting on my CentOS box to download. And I probably won't come back and do this later once it downloads. This just doesn't seem really that relevant to me right now, so I'm just going to get first exposure to it so that if it does happen to be relevant later, I can remember, oh yeah, I did read about this, I'll go back and look at that. But for now, we're just going to plow through. Note how the GPG check value is 0. This means we haven't signed any packages, and yum should not try to verify a signature, preventing a failure in this example. Searching for the package should now be possible, giving us the description as part of the output. So here's another command, yum. I won't get that until I have my virtual machine. The search function works correctly. Installing the package should work as well. Removing has to work as well. Okay, so you can remove the package after you install it. You don't need to do any extra steps to set up removal. As long as you can install it, you can remove it. The http.server module should display some activity, demonstrating that yum was reaching out to get the hello-world package. Alright, next part is management with systemd. Systemd is a system and service manager for Linux, also known as INT system. It is the default init system for many distributions, such as Debian and Red Hat. Here are some of the many features systemd provides. So this is good news because it's for Debian, and Ubuntu is Debian based, so I should have systemd on here already. Oh, command is not found. Let's see if I can get it. I can't get it. Let me do a apt-get update. There we go. And now let me try to get systemd. Okay, but here are some of the many features systemd provides. Easy parallelization, I think. Parallelization? Let's figure it out. Oh, can I get a pronunciation in here? I can't. Okay, well, I'll just type it up. Parallelization, I think is how it's pronounced.
Parallelize. Parallelize.
Parallelize. So parallelization or something? I don't even know. Parallelization. It doesn't even have like this actual word in there. Yeah, I can't get a pronunciation for this word. And parallelization. I think that's how you pronounce it, parallelization. Like parallelization. Difficult to pronunciate. Hooks and triggers for on-demand behavior. Logging integration. Okay, so and then the final feature that systemd provides is the ability to depend on other units for orchestrating complicated startups. There are plenty of other exciting aspects of systemd. Let's see if I can get systemd. Okay, perfect. I have it now that I have my apt-get repository updated. Such as network DNS and even mounting for devices, the idea of handling processes with ease in Python has always been challenging. At one point, there were a few init-like projects in Python to choose from, all with their configuration and handling APIs. Using systemd allows portability and makes it easy to collaborate with others since it is widely available. Tip: two well-known process handlers in Python are supervisor-d and Circus. Okay, so let's see if I can get RPM build now that I've got it up to date. I can't. Okay, yeah, and that makes sense because it's still. Oh, you know what? I think it has a dash. Okay, so that makes sense because I'm using a different kind of Linux that doesn't have RPM build. The only way to get it is by using the yum command, and the yum command is only available on Red Hat-based distributions of Linux. I am using a Debian-based distribution. Not long ago, Alfredo wrote a small Python HTTP API that needed to go into production. The project had transitioned from supervisor-d to Circus, and things were working fine. Unfortunately, production constraints meant the integration of systemd with the OS. The transition was rough because systemd was reasonably new, but once things were in place, we benefited from having the same production-like handling for development and catching integration issues earlier in the development cycle. When the API went into the release, we already felt comfortable with systemd to troubleshoot problems and even fine-tune the configuration to cope with external issues. Have you ever seen an init script fail because the network was not operational? I have not. In this section, we build a small HTTP service that needs to be available when the system boots and can restart at any moment. Oh, perfect. Okay, awesome. The unit configuration handles logging and ensures the specific system resources are available before attempting to start. Oh, that's perfect. So you can set up a like a pretend scenario for your script to fail, and you can see how your script is going to fail before you encounter that scenario. So when the API went into the release, we already felt comfortable with systemd to troubleshoot problems and even fine-tune the configuration to cope with external issues. So they were able to build a HTTP service to see what happens if the network is not operational before even having their script go anywhere near a network, operational or not. Really, really cool. All right, long-running processes. Processes that are meant to be running all the time are excellent candidates to be handled with systemd. Consider how a DNS or mail server works. There are these are always on programs, and they need some handling to capture logging or restart when configuration changes. We are going to use a small HTTP API server based on the Pecan web framework. Note, there is nothing specific in this section as to how Pecan works, so that the examples can be used for other frameworks or long-running services. So pick your web framework. I'm kind of surprised I didn't go with Django. That's what I would have picked. I believe Django is a web framework as well. Yeah, but it looks like Pecan does not aim to be a full stack framework. So this looks like a more lightweight version. That might be why they picked it over Django, because I think Django is a lot more robust. So it's a high-level Python web framework, and this is a lightweight. So this is much more heavy-duty. I've never used Pecan before. I've used Django before, but okay. So let's set it up. Pick a permanent location for the project to create a directory at, and then create a new virtual environment and install the Pecan framework. Okay, so let's follow these instructions here. We can use the Debian machine for this, or the Debian-based machine. This is a Ubuntu distro, but Ubuntu is based on Debian. So we're gonna mkdir, and I don't know what that P stands for, so let's do a help on that, try to figure that out. Parents. If no error, if existing, make parent directories as needed. Oh, that's kind of cool. Okay, so this means if I don't have a OPT, it will automatically make the OPT for me. But I do have OPT. But we could, let's say, so let me go back to my home. You can see I don't have a directory here named my directory. So if I wanted to make a directory called your directory, mkdir, I can make that directory inside of my directory as long as I do the -p flag. So let's try to do that without the -p flag. So we're going to say my directory, and then we'll say your directory cannot create directory, no such file or directory. But if I do -p, now I can create the directory, because even though the parent directory for your directory, which is named my directory, does not currently exist, the -p flag will create it. So now I've got my directory, and inside of that is your directory. Cool, I didn't know that. There's been many times where I have needed a -p flag and didn't know that there was one. So I just got creative. Okay, so let's see here. So yep, let's make the directory. There we go, and then we're going to change directories into the newly created directory. Perfect. Python 3-m vnv, and then the dot is yeah. So we're making. So we should have a directory in here named. Oh, I'm not sure what happened there. I wonder if I can. okay, so I guess if you use this dot, then you don't put it in. You just make the virtual directory this own directory. So it's going to be okay. I kind of like that way to do it better. I've never really seen it done that way. I like that. Okay, we got it. Pecan has some built-in helpers that can create the necessary files and directories for an example project. Pecan can be used to create a basic vanilla HTTP API project that hooks up to systemd. Version 1.3.3 has two options, the based and the REST API flavors. Okay, so we've got Pecan now, so we're going to do Pecan PECIN, create API, REST API. Oops, so I see some, okay, so this is just the normal output. I thought it looked like errors to me, but nope, no errors at all. Yep, and this matches what we got here. Tip, it is important to use a consistent path because it is used later when configuring the service with systemd. By including the project scaffolding, we now have a fully functional project with no effort. It even has a setup.py file with everything in it, ready to become a native Python package. Let's install the project so that we can run it. Okay, so we don't have that install file. Oh, you know what? That's because, yeah, so that's because we followed the instructions. So this is where it gets tricky. They want you to, you have to change directory into the API or specify a relative path pointing to this setup.py file, because we can see that file is actually in the API folder here, which looks like we have another API folder. What's in there? Yeah, I'm not sure what that's all about, but you can see I entered the command in exactly as they gave it. So unfortunately, there's just a typo in the book. Here's the command I entered. But yeah, create API, REST API. So I entered the command correctly. It's just the book has a mistake in it where it doesn't tell you to change directories. Okay, but now that I'm in the right directory, it's going to, yep, it's going to work. Yeah, and that's unfortunately something a lot of tutorials aren't clear about, is what directory you need to be inside of in order to run things. The Pecan command line tool creates a configuration file. The configuration file has always been created for you, has already been created for you by the scaffolding, and it lives in the top directory. Start the server with the config.py file. So they're doing a relative path to the config.py file, so the folder they're in is a folder that contains this. So let's see if we're in the right folder. Yep, we see the config.py file, so we can run the command using the same relative path that they gave. They don't have to specify a path, they can just specify the file because the file is in the directory they're in. There we go. So now we've got a HTTP server running. Testing it out on the browser should produce a plain text message. This is how it shows with the curl command. A long-running process starts with pecan serve config.py. The only way to stop this process is to send a keyboard interrupt with Control-C. Starting it again requires the virtual environment to be activated, and the same pcon serve command runs again. Okay, so first of all, let's try to get a curl there. So I'm going to need to do this in another screen. There we go. That's the only way I know how to do it. I wish there were a better way, but I wish the book were clear about that. I mean, that's why it's just hard to like for me. Like, you know, I'm pretty well advanced. Like, if you were to put me next to somebody who like was an actual intermediate to beginner, I'm sure I would not. Like, I would be on some things too far ahead to really help the self-confidence of that kind of person. Like, there's just no way you could possibly classify me as a beginner. I am solid intermediate to advanced at Python, so I know how to create a screen and run the script in a way where I can minimize the Linux window and run it from another window. This book does not say how to do that, unfortunately, so it's kind of a big miss from this book. I wish they'd be more clear about how to simultaneously run the server and do this curl command. One way you can do that is with screen, which is how I'm doing that. But I'm sure there are other ways. Unfortunately, this book won't let you know what they are, which is a shame. I really wish the book would be cooler about that. But we can see now that we got the server running, we can do a curl, which is just a request out to it, and we get something back. So let's switch screens, and we should get some. Yep, there we got some logging messages. So we can see we got a get, HTTP get, and then we got a 200 response. So it was successful. Okay, so a long running process starts with the pcon. So that, yeah, let's see how we can make it a long running process. Oops, I did server. The command is going to be serve. Okay, so now this is what's called a long running process. The only way to stop this process is with a keyboard interrupt. Okay, so I don't know what they mean. So it almost seems like what they're saying is if I do a deactivate, and if I do a what? I guess there's no deactivate command. Okay, well, I don't know how to. Oh, you know what? It's because I'm in the wrong. Yeah. I'm in the wrong folder. So I've got to go into the. Which folder do I need to go into? Oh, yeah, I needed to go into this folder here. Okay, so let's just try it from here. So we're going to do pcon serve config.py. Perfect, and then we'll do a control C. We'll do a deactivate, and then we'll activate this again through the command source bin activate. Actually, we gotta do that one higher though. Source bin activate. It's a relative path. There we go. Oh, and it didn't run again automatically. So I don't know what they're talking. I don't know what the difference is between this serve command and oh, and now I can't even. Oh, I'm not in the right. Yeah, I've got to go into the API because I'm specifying a relative path is relative to the directory I'm in, so I wasn't in the correct directory. So yeah, that's a different command. You can do pcon serve, or you can do pcon serve. Those are the same commands. What the hell? Oh, okay. So I thought they were explaining the difference between a default way to run it and another way to run it that creates a long running process. But that's not what they're saying. They're saying that the command pcon serve is the only command you use to run pcon. In this example, they're not saying that they're introducing two different commands. They're just introducing one command. And they're saying that one command creates a long-running process. And a long-running process is something that just takes your command line away from you until you hit Control-C. I thought the confusion came in that I thought there was a way where you could run it so that it hangs up on you like this, and then you don't get your command line back until you hit Control-C. So clearly we can see that, but I thought the book was going to introduce another way to run it, where instead of hanging up on you like this, and not giving you back your CLI until you hit Control-C, you run it, and it gives you back your CLI, but it still runs in the background even though you still have your CLI. I thought the book was going to explain how to do that. That's the way I would prefer to do it, because losing my CLI like this is not the preferred way for me. I'd rather these logs just go into a file and look at that file. There's a command called tail-f where you can basically get this kind of output where you would see in real time things populating, but as it's in real time written to a file. So if you just use tail-f, you get this same kind of interactive output, and you don't need to worry about somebody accidentally hitting Control-C or like something like that. The systemd unit file. Unlike older init systems that work with executable scripts, systemd works with plain text files. The final version of the unit file looks like this. Okay, so we're going to need to make a unit file. Save this file as hello-world.service. It will be copied into its final destination later in this section. Okay, so we can just make it wherever we want to make it. I would like to make it one up under here. So I'm going to make it using nano, and it's going to be called hello-world.service. Yeah, and this is where I wish you could just copy paste from the book, but typing exercises aren't the worst thing in the world. The big problem for me though is the word wrapping and not knowing exactly when there's a new line and stuff, especially when Python code examples are given. So if there were a better way, so as I talked about many times in the past, learning from Kindle like this is not bad. It's working for me, but there definitely are limitations. Yeah, like even here, I don't know if it's supposed to be on another line. I'm guessing it's and the other thing is I don't know if this serve here gets a space or not. Yeah, there's just no way to tell if that serve gets a space or not. But we'll learn how to read errors. So if that gets an error, we'll look into that and then try removing that space and see if it works better. There is a strong clue as to the syntax of this file with these equal signs here. Each of these are going to go on its own line. Oh, I forgot a Y. Okay, so we've got the file. Hopefully the syntax is good. We'll find out later when we run it. It is essential to get all the section names and the configuration directives correct, as all are case sensitive. If names don't match exactly, things won't work. Let's go into detail for each section of the HTTP service. Unit. Okay, so let's cat out the file and go into detail here. And I'll clear off the terminal so it's cleaner. There we go. So unit is right here. Provides a description and includes an after directive. So here's the description. Here's the after directive. That tells systemd that this service unit needs to have an operational network environment before being started. Other units may have more complex requirements, not only to start the service, but even after it starts. Condition and wants are other directives that are very useful. So in addition to description and after, I could also have condition equals and wants equals. But the next section is service. This section is only needed when configuring a service unit. It defaults to type equals simple, which we've got. We're using the default. Services of this type should not fork. They have to stay in the foreground so that systemd can handle their operation. The exec start line explains what the command should run to start the service. So here's the exec start. So we're going to run. Okay, so we're going to run this pecan command. So we've got a absolute path here, so it doesn't depend on where this script runs from. This is an absolute path pointing to a executable. Pecan is an executable. So this is just like the command we did before, where we did pecan serve. We're doing the same command, but instead of using the system, I believe it's a system variable. Oh, I forget how to do it. I think it's like echo path bar. Oh, it's going to be lowercase. Yeah, so it's like these here are like if I run a command if I run something that's absolute like this, it can by default run it as an absolute. It can run it as an absolute file path because it has all of these paths to work with. So path is not relative. It is not yeah, it's not a relative command. Like you can see, there's nothing here that says path, but because I've got these loaded in as these like path variables, it knows that it can check in any one of these, and it happens to be in opt http-bin. Okay, so that's why that looks different, because we have a absolute path to the executable instead of a relative path that depends on my path variables. Okay, but then we got the good old familiar serve command, and then we've got the familiar specification of the file as well. But like for the executable, we have the absolute path instead of the relative path. Services of this type should not fork. They should have to stay in the foreground so that systemd can handle their operation. The exec start line explains what the command should run to start the service. It is crucial to use absolute paths to avoid problems finding the right files. Although not required, I've included the working directory directive to ensure that the process is in the same directory where the application lives. If anything updates later, it might benefit from already being in a position relative to the application. So you can set your working directory through this working directory setting there. Both the standard output and the standard error directory directives are great to work with and show how much the systemd has to offer here. It will handle all the logging emitted via stdout and stderr through systemd machinery. We will demonstrate this further when explaining how to interact with the service. Okay, so this is pretty awesome. I like this. So I'm going to highlight something here. I'll just highlight I'll highlight this. There we go. I just want to save this because this is I'm going to need to do this a lot. I need to take a minute here. I'll be back. All right, I'm back. So the next part that we can see here is install. The wanted by directive explains how this unit handles once it is enabled. The multi-user.target, which is fed into wanted by here, is equivalent to run level 3, the normal run level for a server that boots into a terminal. This type of configuration allows the system to determine how it behaves once enabled. Once enabled, a symlink is created in the multi-user.target.wants directory. All right, next section is installing the unit. The local file itself has to go to a specific location so that systemd can pick it up and load it. Various locations are supported, but /etc/systemd/system is for units that are created or managed by an administrator. Tip: it is useful to make sure that the xstart directive works with those paths. Using absolute paths increases the chance of introducing a typo. To verify, run the whole line in the terminal and look for output similar to this. Okay, so we're going to run this whole absolute path line that we added to the file. So we'll copy it from the file because that's where it's going to get run from. We need to test what's in here. So we'll take it out of there and we'll run it. There we go. We won't have any problems. Oh, what happened? Okay, nothing happened. I think. Yeah, nothing happened. Okay, perfect. After verifying that the command works, copy the unit file into this directory using hello world.service as the name. Okay, so we're going to move it. It doesn't need to be here, so we'll just move it out of here instead of copying it. Okay, we need to put it in etc systemd system. There we go. So now it's no longer here, it's at that location. Once in place, systemd needs to be reloaded to make it aware of this new unit. Oh, system has not been booted with systemd as a init system. Can't operate. So I think I need to reboot the system. You know what? I'm going to put this into Google and we're going to figure this one out. Yeah, because the book is kind of leaving me high and dry there. So we got to go to Google, figure this one out. So, okay. That didn't work. That didn't work either. Huh. This didn't work either. Do I need Docker? It's not a Docker command. It's a systemd command, I thought. Yeah, I don't think. I mean, that's the problem with Google sometimes. Like you'll find an answer, but sometimes the answer is just not relevant to what you were doing. Okay, so let's try. Yeah, let's try to get this command to work here. So we're gonna do system ctl daemon reload. Okay, system has not been booted with systemd as a init system. So okay, so I think it's because I apt installed it. But I didn't reboot the system after doing that. So let's try that. So we're gonna do, first of all, we don't need this now. We're gonna, okay, so I did an exit, so we'll start it up again. And now hopefully that will be the answer. Huh. Gotta, I think it'll just take a little bit of time here to come up. Okay, there we go. And for some reason it installs. You know what? This might be a systemd. There might be a systemd file already on there that's forcing this to happen. Okay, let's see if this works now. Nope, system still has not been booted with systemd as init system PID1. So, huh. Yeah, I don't know what to do about that. I thought I could find where that. I thought I could set. Thought I could set system D as a init system somehow, but I don't know how to do that. So I've got to set it as a init system. Yeah, so they're talking about the Windows subsystem for Linux. I'm not using that. I'm using a VM. Okay, your Linux system is not using systemd. The reason that you are trying to use systemd command to manage services on Linux, but your system doesn't use systemd, most likely using the classic sysv invid system. Okay, so let's see if this command works. Nope, not found. How is this possible? You are using Ubuntu, and the tutorial is also for the same version of YouTube. How come it's not working for you? If you are using Ubuntu inside Windows using WSL, I am not using it inside WSL. Use this command to... Okay, so let's see what is mapped to PID1. Oh, bash is mapped to PID1. So the first process that runs in my system is bash. It runs actually before systemd runs. So how do we fix it? Okay, well they're saying to use, oh, you know what? Oh, what if I just use the service command? Okay, so yeah, that's what's going on. I can use, so basically I can just swap out one-to-one. Well, not one-to-one, but so here's the equivalent command. So I have to use these sorts of commands instead of these sorts of commands because of the kind of Linux, because of how I'm running Linux. It'd be nice if I could set up systemd, but you can see I did set up systemd. I have it, but it's not. It doesn't take prevalence over over this. So let's try it. Let's try it with service. So okay, yeah. So we'll try service system daemon reloaded. Oh, you know what? Okay, let's just keep on going. The service is now fully functional and can be started and stopped. This process is verified by using the status subcommand. Let's go through the different commands you can use to interact with the service. First, let's see if systemd recognizes it. This is how it should behave and what the output looks like. Okay, so you know what? Even though I wasn't able to restart it, maybe I can still use it. Let's give it a try. Nope. Okay, so let's try the other command. Okay, unrecognized service. Unrecognized service. You know what? I think I need to be in the. I think I need to be in the right directory. Yeah. So, what directory do I need to be in? Okay. I think I need to be in, yeah, let's go to that directory. There we go. So we've got, yep, we've got the hello world.service there. So let's do systemd hello world. So access arguments. Shoot, I really want this to work. God damn it. Okay, so let's see the equivalent of the status command. Okay, so it's going to be just flipped. Okay, so, well, dang. That did not. Yeah, this isn't working for me for some reason. Shoot. Okay, so since the service is not running, it is not surprising to see it reported as dead. Start the service next and check the status once again. Curl should report nothing is running on port 8080. Okay, so let's do curl local host 8080. Okay, we've got nothing connecting. Okay, so now let's do a system ctl start hello world. Same thing. Damn it. That is really frustrating. Let me see if a different box will work. So right now I'm using this one here. So let's use a Ubuntu Docker box. Okay, and now let's try that command. This command here. Let's try that one. Failed to connect to bus. No such file or directory. Oh, you know what? This uses the service as well. I wonder if this is Red Hat. If it is, that's fine because I just finished it. So let's see if we get better results using a Red Hat VM. So we'll do a new template. We'll do install from the server. Then we'll do guests, and we're going to do CentOS. Yep. Okay, so we're going to import the file that we just downloaded under downloads. Here we go. Okay, and now unfortunately we're going to need to wait for that file transfer to complete. It says it's not the correct file. Yeah, let's just do it. Why is it not the... Should be the correct file. Okay, anyways, it looks like this one's going a bit faster since it's not on the... Or, yeah, this one's going a bit faster. It's already at 5%. So let's keep on reading. I would have really liked to have this working, but let's keep on going. The service is running and fully operational. Verify it once again on port 8080 to make sure that the framework is up and running and responding to requests. Yeah, so it didn't work for me. If you stop the service with systemctl stop hello-world, the curl command will report a connection failure once again. So far we have created and installed the unit, verified it works by starting and stopping the service, and checked if the Pecan framework is responding to requests on its default port. You want this service up and running if the server reboots at any time. This is where the install section helps. Let's enable the service. There we go. So there's symlink created. when the server restarts, the small HTTP API service is up and running. Perfect, I love it. Yeah, so I'm gonna do this again because there's so much need for this. There we go. Okay, so the next section is going to be log handling. I'm going to get to it. I just need to take a quick break. So, yep, I'll be back shortly. Okay, so I'm very nearly at the end here, but unfortunately, I got to do one more video for chapter 5. I just can't finish up chapter 5 tonight. I wish I could, but I really can't. So I'll see you in the next video for the end of chapter 5.